Okay, welcome. In today's video, we're going to prove that every polynomial is the sum of an even and an odd function. Okay, so basically what it's saying is that you have a polynomial, and that polynomial can be written as the sum of an even and an odd function. So how do you approach this question? Okay, so I'm going to show you that. So we're going to let that, okay, there is a function f of x, okay, and there are two components, g of x, okay. So yeah, there's a function f of x, and there are two components g of x and h of x, such that g of x is even, okay, and h of x is odd function. Okay, so you're gonna let this thing, so if this statement is incorrect, then this will be a proof by contradiction, and if this statement is true, then we're gonna have a unique solution. Okay, so we'll write this down, then you'll understand it further. So okay, there are two components, g of x and h of x, such that g of x is even and h of x is odd. Okay, so we have the function f of x, and f of x is divided into two components, g of x and h of x. If you add them, you're going to get h of x, f of x, such that g of x is even, h of x is odd. Okay, so now we're gonna write another equation from the definition of even and odd function. Okay, so what are you gonna do? We're gonna compute what f of minus x is. Okay, so the additive inverse. So even and odd functions are defined from its additive inverse, that the even function is equal to f of minus x. Okay, and odd function is equal to, okay, if you don't know the definition, then you can divide, look for the definition. Okay, so f of minus x will be same thing as g of minus x plus h of minus x, because these two are the parameters, and if you're going to compute f of minus x, you have to put minus in the parameters. Okay, so we know g of x is an even function, so by definition this should be g of x, because g of minus x should be equal to g of x from the definition of an even function, and h of minus x is an odd function, so from the definition it should be minus h of x. Okay, so I hope this is clear. This should be minus h of x. Okay, so you have this equation here. Okay, so we got two equations now. This is the first equation, okay, that we know that is the combination of even and odd function, and here's the second equation. Second equation is computed by computing f of minus x, and we have this first equation and second equation, adding them both. Okay, let's add them both. What do you get? So if you add them both, you'll get f of x plus f of minus x is equal to g of x plus h of x plus g of x minus h of x. Okay, so this will be f of x plus f of minus x is equal to h of x, and h of x will cancel out, 2g of x. So we're gonna have a unique solution for g of x, which will be f of x plus f of minus x divided by 2. This means that that one component can be written as this, which is the even one. Okay, so you can verify that this is even. Okay, or if you are satisfied that this will be even because we computed it from the definition of an even or odd function, then that's also correct, but you can verify that it's even as well. Okay, so let's go next. Okay, so now let's go compute what h of x is. So we know that f of x is g of x plus h of x. Okay, and f of x will be equal to, we know what g of x is, we just calculated this. Okay, so this is f of x plus f of minus x divided by 2, because we calculated this here. As you can see, g of x is f of x plus f of minus x over 2. Now from this we can calculate what h of x is. So h of x will be f of x minus f of x plus f of minus x divided by 2. So this is all minus. Okay, so if we subtract this thing from f of x, we'll get f of x minus f of x minus, okay, wait a minute, I'm wrong. So you'll get f of x minus f of minus x divided by 2. Okay, so I just wrote the result, that this will be 2f of x minus f of x is going to be f of x, and then distribute the minus sign, so you can have minus f of minus x. So h of x is this thing, and again h of x, I mean for h of x we have a unique solution, and as we have found g of x and h of x as a unique solution, we have proved what we wanted to prove, that f of x is the combination of an even function and an odd function, and then the even function will be thus g of x is equal to f of x plus f of minus x divided by 2, and h of x will be f of x minus f of minus x divided by 2. Okay, so I hope this was helpful. If you want to prove that whether this is even an even function and whether this is an odd function, then you can plug in the additive inverse g of minus x. Then g of minus x should be equal to g of x, and you can verify this. So this will be f of minus x plus f of x, because this x will take the value minus x, so you change it into f of x divided by 2. And as you can see, this is just the rearrangement as this, so this is indeed equal to g of x, and we can see that this is even. In the same way we can see that h of x is odd. Okay, so h of x is going to be, okay, h of x is odd. How do you prove h of x is odd? If you compute h of minus x, it should be minus h of x. Okay, so let's plug this in. So you're gonna get f of minus x minus f of, this should be plus, divided by 2. If we have minus common, minus, if you factor out minus 1, then what you get is, it will be f of x minus f of minus x divided by 2. And as you already know that this is h of x, okay, because h of x is f of x minus f of minus x divided by 2. This is the same thing, so this is minus h of x, and here you can see that h of minus x is equal to minus h of x. It means that h of x is odd. Okay, so we were able to get g of x and h of x from f of x such that the components are, one is even and another is odd, which means we have shown it. Okay, so I hope this is helpful. And these two formula also can be helpful to find out what components are even and what components are odd of the function. So all you have to do is you have to write the f of x, then you have to add f of minus x and divide by 2, then you'll get the even component. If you do this computation, then you'll get the odd component of the function h of x. Okay, so I guess this video is helpful for you.